great to be back here at Lambda Days. Last year, you might have seen me at the check-in booth because I was a volunteer. This time I have the honor of speaking and introducing an awesome framework for TypeScript I stumbled upon called Effect-TS. Oops. If you take a look at their GitHub homepage, Effect-TS Effect, they have a quite bold statement. They claim that they provide an ecosystem of tools to build robust applications with TypeScript. But first of all, how many of you use TypeScript on a daily basis? All right, around, I would say, 45% of the people. And how many of you are just here because you are curious maybe about the functional parts of TypeScript? All right, maybe 60%. That's awesome. Continuing the big, bold claims about Effect, this will say, oh, they provide the frameworks and like the toolings for writing TypeScript in production. And the truth is, TypeScript and JavaScript APIs are severely limited when it comes to production-grade applications. We need to keep reinventing the wheel all the time. We have tools and APIs at our disposal that are suboptimal. If we need to do anything that goes out of the ordinary or out of the happy path, we either need to reinvent our own control modules, essentially, or we need to just go wing it and then see our application breaking in production on a Friday morning. The reality is, there are so many features that are being added to JavaScript year by year, but this adoption is kind of slow. And in 2022, the State of JavaScript survey, basically most people claimed that they wanted a new standard library, immutable data structures, they wanted to be able to observe objects, they wanted a pipe operator like the one you have in Elixir, where you essentially you pass the value of the first the result of the first function as the first argument to the next function, and then pattern matching, which is typical of functional programming languages. Fantastic, a network isn't showing up, but here you will have seen that Effect is voted as one of the five best tools in open source for JavaScript for this year. This was the Effect Days conference in Vienna last February, and you can see my face right here. That was the first official conference about Effect. And I mostly went there because I wanted to see whether it was just hype, just words, yet another VC company that wants to get clients via an open source library and then perhaps try to force them to use their own services. And I wanted to understand whether there was more to it, right? And turns out there is more to it. You might recognize John DeGoes. He's very popular in the Scala ecosystem, I'll say, for the ZO library, for the contribution to the ZO library. And the reality is that Effect was born as a port of the ZO2 library to TypeScript. And John DeGoes goes as far as saying Effect is now bigger and has more chances of becoming popular and improving the lives of developers than Scala, simply because TypeScript has many more developers. There are so many packages distributed in NPM and other registries. And truth be told, it's a bit easier to find TypeScript developers than Scala developers. And the fragmentation also in the Scala ecosystem is quite large. This is me. I'm Alberto Schiabel. You can see me online at Jcomino. I mostly deal with TypeScript, Rust, WebAssembly. I'm also a consultant and contractor. My interest for Effect arises from my own frustration in writing with TypeScript every day and having to deal with complex pipelines, even FFI bindings. Things may break all over the place. And I want something that streamlines all those problems. So today we're going to understand the limits of a typical TypeScript application. We will showcase how Effect solves many of these problems in a way that is kind of coherent and cohesive. We're going to just provide you some concepts for you to dive deeper into Effect if you're interested, so that you can kickstart. Because the curve is a bit steep, right? So we're going to try to make it easier for you. So first of all, what is a program? You may say it's just a series of steps that we want to execute. More accurately, it's like a description of these steps that we want to compute. And these steps can be can have several different forms. It can be synchronous, it can be asynchronous. They can depend on external services. They can depend on maybe I/O access or HTTP access. And everything may fail all the time. We have different kind of errors. They might be some of them might be retriable. Some of them indicate that your app just needs to die, and you restart. You need to find a log somewhere. And ideally, you have like telemetry and monitors for every endpoint of your REST APIs or things like that. Otherwise, if things go harshly, you're not gonna really know where to put your hands to fix the problem. And TypeScript, in theory, has a capable enough type system. Yeah, perhaps yes. Try, all right. That's easier. TypeScript has a capable enough type system to allow you to encode all of these informations about the types, the dependencies you're using at the type level. And why will that be useful? Because it will indicate at an immediate side what a function does, what it needs, how it can break. You know that if you have a function that might throw an error, the error is not indicated in the type signature. But if you use perhaps Rust or Haskell, usually you have that in the type signature. And if you need to refactor something that uses one particular I/O, for instance, just file disk access, you need to replace all of these methods with something else like HTTP access, then it would be easier to perform that refactoring if that kind of resource, external resource being used by the function, which makes the function impure, was encoded and reflected in type signature. But most apps do not really exploit this capability of TypeScript. So for instance, here we have a divide function. You know the drill. If you divide by 0, you get an error. We have an explicit error within the body of the function. But at the type signature, you see we have no real information about that. So if we only see like we hover on our editor and we look at the type signature, we have no idea whether it will fail or not. And you know, we are functional developers, so we might roll our own either wrapper. Will that really fix the problem? Well, let's see. We have an either wrapper just returns a success value or an error value, depending on the case. But whenever I try to, here we see that we can divide by 0, but whenever we try to use that and try to compose it with some other function, we see that we always need to inspect the value of our own wrapper. And if the value is an error, then we need to essentially short-circuit the function and exit early. And as you see here, you might imagine you can have several levels of nesting, and this is not really something we would like to have. Another thing, when it comes to external dependencies, let's say you want to generate an ID. In order to do that, your system will pull a part of your operating system and then also of your internal hardware to basically check for randomness and get some random data out of it. Turns out, in certain scenarios, this can lead to failures, especially if you are in such a fragmented ecosystem as JavaScript, which, by the way, has just gone through a Python 2, Python 3 scenario, in which there are packages encoded in different shapes. They might break all the time. I stumbled on this error, and my tests were working fine, but then I deployed the application in production, and the application broke just because I had a different version of Node.js, for instance. So having an indication that certain kind of low-level dependencies are used, they will be easier to spot these kind of things. Similarly, I was working in our repository that was performing so many disk accesses, and it was always pointing to the same parts of the disk. So we were trying to debug why it was low, and there were so many functions, essentially, calling the same fs.read, so file system read, with the same file. What if there was a way of just finding them, looking at the type signatures, so that my editor will find them much sooner, without me needing to know exactly the value of the file name that was accessed? And asynchronous functions, those are a bit of a wild beast. They are a fairly recent addition to JavaScript, and usually they go like that. You have a fetch call, so like an HTTP call, and then you get the response body, and you interpret it as a JSON. And pretty much everything there might fail. By the way, this is running, but why can't we see anything here? If we log the promise, if we log the value here, we just get a promise and then some, there is some transparent data within, and we just see empty brackets. That is because promises are opaque values. First of all, the moment you call them, they run straight away. So they are eagerly evaluated. And once you call them, there is no way to basically to halt them. Unless you write maybe 30 lines with an outboard controller API, which has just been recently introduced. It was not even part of the original API proposal for promises, which makes things a bit weirder. Now, if we want to look at the values, we need to await the promise first. So we need to wait for it to succeed or fail, and then we showcase what happens there. What if we try to fetch from a URL that is invalid? First of all, promises, they encode a single value, right? If you over here, you should, perhaps not, but that will show me that this function returns a promise of any. But it can also fail, and if it fails, it doesn't tell me any information about the error. In fact, if I run this, it tells me there's a type error, it failed to fetch. Of course, we're calling the wrong URL, but at the type signature, we have no idea whatsoever what's going on. Here is a scenario with a happy path. We just use the async await syntax, and we don't really care about any errors along the way, but there can be possible errors. And if we really wanted to deal with them, we might need to write something like that. And there would be a try-catch, and then another try-catch, and then a bunch of ifs in between, and the return type changes depending on everything that you're basically checking. So you might have a union of results. And nobody really wants to write code like that, I hope. Then you have certain methods available, like how do you deal with multiple promises? What if you want to run them all? You can use promise.all. The thing is, here I'm looking at 5 to-dos. I'm giving them IDs in order, 1 to 5. The thing is, if I run this, now it says it receives first the first result, then the fourth result, the second, the third, and the fifth. So they run in whatever order they prefer. The order of execution is not guaranteed. Actually, all the promises are executed pretty much at the same time. So if you have like 1,000 requests to perform at once, that is going to cause some hard problem on your server people. The results, at least, are going to be ordered, but the time in which they are constructed, that's just totally random. So promises are really broken. So they're not really type safe. Errors are not modeled at all. You have no real way of composing them. The moment you run them, you're already lost because you lost track of the handle of the promise. You have no idea whether it's still pending, whether it has resolved, whether it is in an error state. If you create a promise and then you want to cancel it, it's very hard to plan for that. Like you need to think carefully about that. And there is no built-in retry logic. So if an invocation to your server failed, maybe you're in a React application or something like that, you need to manually implement your own restart mechanism. Maybe you want a backoff, exponential backoff. Maybe you want a simple wait 3 seconds and then retry. You need to write it every time for every project you deal with. So at some point, you might gonna create your own standard library. But do you really want to? So a library came up a few years ago to try to solve some of these problems. And this is by FPTS, by Giulio Canti. He is really a TypeScript wizard. He saw the problems with promises. He saw that category theory provided us certain tools to help us out. And like the results are amazing. First of all, he distinguished promises that can always succeed and called them tasks from promises that may fail, and he called them task either. And also notice that all of them are lazily evaluated. Like you have like a factory function. And you can encode the type of errors this way. And it has like a declarative API, so you can also run them one after the other. Or you can also compose them in a certain way. Thing is, you still have very different semantical models when it comes to synchronous and asynchronous computations. So it's hard to integrate them. And if you want to do that, you're going to have a hard time. You're going to write a lot of code. And most likely, you're going to ask for help in the Discord. Because the documentation is not really clear. I mean, you just have type signatures. If you know Haskell, if you know, not Elm, but the other, how was it called? PureScript, yeah. Or Scala, you might find some familiarity and similarity there, but otherwise you're kind of on your own, or you need to ask on a Discord or on Stack Overflow. Fun fact, by the way, Giulio Canti was the first person to emulate higher counted types in TypeScript, thanks to a paper by Yalop from 2014. And why do I talk about FPTS? Because at some point, like last year or 2 years ago, FPTS and Effect, this port of Zio, they joined forces. So rather than competing, they saw the benefits or uniting forces and also having a uniform API. They already had some similarities here and there, but FPTS was stronger in the primitives, and Effect was stronger in the higher order and like developer experience overall. And Effect solves many more problems. For instance, so first of all, they provide a fully fledged functional effect system with a rich standard library, but it's a standard library that kind of makes sense. Everything is modeled in the same uniform way as an effect. We see here an effect has like 3 generic types. The first one, it models the success value. The second one, it models the possible errors that your application may have. And it's not just a single error, like the plural, I mean the plural. You might have an HTTP error, a configuration error, you might have a memory error, and basically you can run this Effectful program, and then you can pattern match on the kind of error you get, and depending on what you get, you might need to perform different retry strategies or just abort your application. And finally, you have the requirements. They indicate the external resources you want your application to access. So for instance, if you want to access a database, you might just indicate that you need a database context. And then at the type level, you're not going to be allowed to run the Effect program without providing an implementation of it. So it's kind of a dependency inversion mechanism. And it's also quite similar to other things you have in Scala for this. Depending on the kind of values you provide, you might have different behaviors. For instance, if you never provide a requirement, essentially you have the either type, right? Because the first one is the success value, the second one is the error values. Or if you don't provide the success value, then if that's just a never, that means that the effect runs forever until it encounters a failure. Or you might, if you don't have any error, then this means that this effect isn't expected to fail. Now, of course, this doesn't mean that the application will be surely working 100% of the time, because you might still have memory errors, and you might still be using functions that you haven't kind of tracked with the effect primitives, but you get the idea. As long as you use this as the main entry point to your application, and as long as your kind of team is consistent to avoid using APIs that can break or have errors, such as JSON.parse, for instance, then you're going to have a much safer journey towards your application. And the important thing is that all these effects are immutable. They are every effect function that produce values, right? And these values are lazily evaluated, and they are just like the program declaration we spoke earlier. Synchronous computations, asynchronous computations, and computations that need an external resource, they are all modeled in the same way. And every effect can be also run either sequentially or concurrently with different level also or concurrently concurrency decisions. You might also use like queues and streams on them. It's very composable, type safe, and every common data types, such as either, are also implemented as an effect. So you have the highest composition possible. And we will see a few examples of this. Most of them are maybe familiar to you, like an option, an either. There's a cause data type that tells you how things may fail in a program. There's an exit data type that tells you, essentially, all right, this program, if it succeeds, it has this value. If it has an unforeseen error that we did not bother to pattern match on and catch, then it's going to fail with that cause of exception. And then you have like a very cool thing for TypeScript developers here is that we have a custom implementation of hash sets and hash maps. And why are they important? Because dealing with them on custom data structures is a pain. So here's an example. Actually, I'm going to skip ahead a little bit. Here's an example. We have a set, and the first two values are objects with name and age property. The first two values are identical. They're at Jacomino. And then we have another one at Ghost. If we compute the size of the set, JavaScript is going to tell us this has size 3. Even though, like, structurally, the first two are equivalent, so we will expect size equal to 2. Why is that? Because referentially, the first two objects, they are different. They have different addresses in memory. And TypeScript, by default, is going to use just the equality operator, and that's how it works. But usually, if we want to maybe have the user writes something in a to-do list, and we don't really have a server, we just want to filter out the duplicates, we may want to use a set. And this implementation will not filter out the duplicates. But for instance, Effect provides something called, well, we have the hash set, and then we have this data struct. This is just like a standard record object, right, with a default implementation of unequal and hash traits. So you might be familiar with traits from Scala or from Rust, perhaps. They have like sane defaults. So they optimize for structural equivalence rather than referential equivalence. In this case, we see that the output is 2 with the affected data structure. So we talk so much about effects, but like, how do we declare them? How do we run them? How do we compose them together? So here's kind of our old example. We have the divide function. This time, that's asynchronous. We have like a promise reject with an error, or a promise resolve with a division value. And we also have an increment function that just plain synchronous. And then we have task 1 and task 2. They just resolve to a certain number, 10 and 2. How do we transpose them to the effect syntax? First of all, we import effect from effect. The case for synchronous computations is very easy. We just use effect.sync. That would be kind of like the pure method for an effect. And we just have that callback, and then we return whatever implementation we want to have. For the division case, that used to be a promise. Now we just return an effect. And look at the types. The first type is a number, that's like the success value. And the second time is an error, a generic error. We use effect.fail and effect.succeed rather than promise.resolve and promise.reject and promise.resolve. And then for task 1 and task 2, if we want to deal with a promise, perhaps because maybe we want to wrap existing APIs that effect might not provide that use promises, then we just use effect.promise and a callback. If we don't want to have a generic error, because that really doesn't tell us much, we might use a tag error from the data module of effect. And still, the implementation is kind of the same. We just see that the second generic type for the divide function changes from error to division by 0. But how do we compose them together? Like, what if we want to run a program that executes them all? And we don't want to inspect the either value or like the effect value every time and just stop early if there's an error, right? We want something that does that automatically for us. So we might use the declarative approach. It's possible. This is still with plain promises. You know, we have the dot done and a dot catch. In this case, we're just modeling the happy path. We have the task 1, dot done, we get the first number, dot done, we get the second number. We call the divide function, and then we increment and return a string saying what the final result is. If we want to have this approach, which I don't really recommend, it will look like this. This will look larger, but still, just so you know, you can have this just called effect.andthen and the .pipe method. Every effect value has a .pipe method. And you may also use the higher level pipe function from the effect package. But what's really most interesting is the async await syntax, right? So if you use plain promises, chances are you just use async await. How will it look like? You just await the first task, you await the second task, you then divide these things, you await on them, and this divide thing can fail. And then we increment something. Increment is synchronous, so we don't need any await there. And here we have like an immediate invoked function, because again, promises are immediately run. And how do we transform this promise of string into an effect of string and error? We use this thing called effect.gen. Then you might see some unfamiliar syntax there. That's a function star. How many of you know what a function star means? All right, maybe 20%. That is a generator function. A generator function, like the idea is that you can start a function. That function you can consume values out of it, but then you can also pause the function indefinitely until you need to consume more values out of it. You can also like generate infinite sequences without bloating your memory this way. But the cool part is that if you use a generator, essentially that's like the async await syntax is a special kind of generator function applied to the promise object. And the cool part is that it allows you to write code that is imperative effectively. You can use the native control flow, like the native if, else, switch, all of that. But you are still composing different effects there. Like these effects we are gathering, they could have different types, different values, different kind of errors. But we're still using the same syntactical operator to access it. And I know it might seem a little bit strange with that yield star. That just means we're just forwarding to whatever generator comes to the right side. So every effect essentially is a generator under the hood. You can just use this in place of await. See? Whenever you have async, you replace that with effect.gen. And whenever you have await, you replace that with yield star. And generators, like they have been really slept upon. They have been introduced, I think, in 2016. And the actual implementation of the async await syntax uses them. But yeah, not many, they're not that used in the industry, I would say. So that's why if you see that in the documentation, that might puzzle you a bit, it might seem strange to you at first. And the cool part is that they give us a similar syntax as the Haskell denotation. So we still have this kind of monad composition thing without really caring about monads at all. We just write imperative code as if we were just starting out with development. But that's the easy thing. Like we don't want functional programming to dominate us and to dictate us how we should do everything and make us life harder, I would say. I think we should just benefit from the beauty and the mathematical proof of it without necessarily having to work at the lowest level with it, right? So this is like a nice abstraction. And how do we execute that? Well, essentially, we need to provide a runtime interpreter. This seems like something very heavy or something that might slow our application down. This is just something that takes the generator and you make sure that the generator output is stopped as soon as an error or anything similar to that is captured. So in this case, we might use run promise because we have some promises under the hood, but really there are, and we see the result is 6. All of these are like A is resolved to a number right away. This is a number 2. We divide them, we get 5, and then we increment 5 and we get 6. We have several possibilities to choose from. If you don't have any promises at all, using run sync might be easier. If you just want to run the application then terminate, maybe that's a CLI command. You can just use run sync exit or run promise exit. If you do custom things with maybe parallelism, then you might need the lower level run fork. This is just for you to have an idea. And what about retries? Like we said that Effect provides out-of-the-box retry mechanisms. And those are quite important, especially in distributed systems, especially when you need guarantees, especially when the network might be unreliable, maybe for IoT devices or for applications in certain areas of the world. So here we have a get-to-do function. We are polling to do API, but also we are setting this so that 70% of the time we're going to have an error. Right? This is just for demo purposes. And we are calling the HTTP API from Effect platform, what it does is essentially unifying all the several different implementation of HTTP clients that are out there, because the JavaScript community has this kind of idea of creating a new runtime every 2 weeks. And none of them follow the standards, really. Node.js tries to, and Bun doesn't even bother. So it's nice that they provide this kind of abstraction for us. And once we call the request, we also try to see whether the response is OK, like so if the status code is between 200 and 299. And then we transform it to JSON. And here we just use the pipe composition. And we return it with a yield here, because we want an effect. Without this, this will be an effect on effect. We don't want to have that kind of thing. And what happens if we run this? If we run this the first time, only a single time, we get an error. We see we got a transport error, failed to fetch at a certain response. What if we decide to have like a custom schedule to retry this application, this computation? What if we first apply an exponential backoff, starting with 50 milliseconds and a factor of 2? And what if then we wait until 2 seconds are reached? And once we reach the 2 seconds of wait time, we just stop there. Like we don't increment that anymore. And we repeat the process until we reach 10 seconds in total. Like this would be hard to express if you rolled your own schedule API. You might have very different ideas. You might have different implementations in different areas of your company's code base. They might be, they may not be very similar. You might need to test them all the time. This just works quite well. You can even write like the duration with strings. It's kind of handy. You might not use this all the time. You might just define a retry schedule and use that once for every part of your application. But it's handy that they provide you the tools to do that. And all right, don't care about that. But if you run this, you may have this run promise. You have the to-do. You have the dot pipe here. We are essentially attaching something to it. And we are attaching this retry, effect.retry method. And what it accepts is a schedule. So we just define the schedule in the previous slide. And one other thing we can do is we can have a log written every time we attempt the reschedule. So we have kind of some context, and that context can be preserved to our own tracing capture logic, or it can be sent to our own OpenTelemetry server. And I think I can show you how to run this. I will need to go to VS Code if all of my tabs are screwed up. So, but I wanted to show you that. Where is my cursor? Yeah, that's fun. Or maybe later. Yeah, I'm going to try later, sorry. The thing about the effect is that there are so much more that I didn't show you today. But hopefully now you have some of the tools to discover more of this framework on your own. Like for instance, what do you have? You have OpenTelemetry built in. Anytime you use effect.log, for instance, you can mark a span automatically in the effect.gen block that you're pointing to, or to the .pipe block that you're pointing to, and that's going to automatically be connected to your OpenTelemetry server. You can provide the OpenTelemetry server configuration whenever you run the program. So from those like run fork, run promise functions. You might have like schema validation, and then there is a talk later this afternoon talking about bidirectional data transformation. You can do that with Effect. You can just use Effect schema, and essentially you have a similar API to Serde in Rust. You can define how a certain record or like JavaScript value is encoded and decoded. You can especially use that to transform begins, dates, and other values that are not JSON's. That are not supported by JSON out of the box, so that you can have transformations to strings perhaps, or to a special format that you control, so that you avoid having JSON serialization issues This is especially handy when you work like with Next.js or like with Remix, because without this kind of thing, you might have type unsafety in your own TypeScript code. You might have a dependency inversion. So, for instance, you wanna swap over the database. You wanna use a different database whenever you are using tests. You might want to point to a different file whenever you're using tests, or you might want to read configurations from a different area of the code base, depending on that could be depending on a feature flag of your application. So it can be quite extensible and programmable. Or more easily, you might want to set up a REST API, and you don't want to spend too much time on that. There is this community-provided package called Effect-HTTP, and it's kind of awesome. You just write your own server routes, and then you have an automatic Effect client for it. That client can be shared. If you have a monorepo, it can be shared with your own React or Vue application. You can use that in place of like TRPC or React Query or similar type-safe libraries out there. And what's the beauty of all of this? You're just gonna use a unified system rather than having a fragmentation of tools that you kind of need to. You need them to work together. Sometimes they work against you. Sometimes they have breaking changes. Those changes might not be consistent with the model, with the programming model you're using in your own projects. And you may say also, well, this is kind of a pitch for a new vendor lock-in. And I really understand the sentiment. And I had the same sentiment before going to the Effect Days conference last February. And what I can tell you is that, first of all, now we have reached version 3 of Effect. Most APIs are stable. Most of the documentation now is written, even for the most esoteric modules. Like you can do very experimental stuff with this, as well as custom policy controls for your servers. But it's there, and like the company has committed to keep that open source. Even though they might start creating maybe software as a service, you're not obliged to use them. They're just going to leverage the Effect ecosystem they created to provide something meaningful for you to use. And by the way, I'm not sponsored at all by them. I'm just fascinated by what they're doing. Another thing you can use, and this is something that has bitten me several times, is utilities that you provide to your own program only at test time. But these are kind of built-in. You don't need to write your own ones like you will do with a database injection thing. For instance, the test clock. How many of you have used Jest for tests and have had problems with set timeout or set immediate? One person, all right. Two people, all right. That's enough. Because you might have noticed that anytime you look for Stack Overflow or even ChatGPT, they are not useful at all for those scenarios. Like they're kind of rare, but when you stumble on them, you have really no way out. So it's kind of cool that they provide you a way of swapping out all the time primitives. And not just that, also the random. You might have a random provider where you can fix a seed and it's used consistently across all your tests. So you can have snapshot testing without failures. Why? We're not really lucky today, are we? And if you want to have more of an experimental Erlang-style server, but with TypeScript, you might try with the Effect cluster package. That's still being developed, but they have like a RPC management system coming right now. They have an actor model implementation that is on the works. And there's so much more. Like I wanted to show you that running, but I have some. I'm going to do that. I'm going to share the links to the repository with you later in the application, so you can try on your own. And please, if anybody of you have questions, also, I'm going to be around at the conference. Stop me. I'm going to repay your time lost at the beginning trying to set up the monitor by showing you that in person. Thank you so much. I will gladly try. I can't even see my cursor. That's maybe. I'm gonna go up here. Maybe HTTP retry. Let's see. Gonna make it smaller. Yeah, that's not. Yeah, that's not the best one. I'm just gonna. Okay. So what was this example? This was the get to do. The get to do might fail. It might fail with probability of 70%. And we're gonna retry on failure, and we are also gonna display a message with this top thingy. In general, any method that starts with top in effect means it's something that applies a function without modifying the value that is returned by that effect. And we're just gonna log that we are retrying to retrieve that object. So I'm gonna run this. Hold up. Okay, and we see first failure, second failure, third failure. If you see here, we have some space in between. This is because of the, in between the timestamps. This is because of the backoff, exponential backoff function. And finally, we get a success. We get the to-do value with ID number 1. And another thing that I wanted to showcase, but perhaps that's a bit more, I don't think we have that much time. I wanted to show you how a non-trivial application might look like. This is a database seeding utility I developed for a conference I did like 4 days ago. This is what I meant when you can buy dependency injection and dependency inversion. Like here, I can request something like this. I can request an ORM, perform a reset of the database, a creation of the database. And really, what this is just a case class. Like if you're coming from Java, that would be just like from Scala, that would be a case class. But we're not really using the implementation. This will be just the definition of something. Like I want something that has that shape, that holds a database. I want it to have like a reference to a user database model. And then usually you have a live implementation. Like anytime you see a live thingy, that would be like a layer or like a service in Effectful Lango. That means it's the actual implementation that is being used at runtime by the main program. Of course, for tests, you will provide a different one. And what do I mean by provide? I mean that at some point at the bottom, whenever you have the main executable thing that you run with maybe effect.runPromise, you have this effect.provide. This provides the environment, the requirements. Remember the third generic type of the effect data type? That's about it. And here you can also compose them. Like you can make one of these service or of these layers rely on the other. You can have even diamond compositions of things. So you can do so many things with that. But yeah.